Elon Musk recently stepped onto a stage and unveiled what Tesla claims is a revolutionary new electric vehicle motor. Within hours, engineers around the world were reacting with disbelief. Many of them shared the same opinion. The performance figures simply shouldn't be possible. According to Tesla, the motor can spin at more than 20,000 revolutions per minute, while helping achieve one of the lowest drag coefficients ever recorded in a production vehicle. The specifications revealed during the presentation challenged many of the assumptions that automotive engineers have relied on for decades. The speed seemed too high, the cost appeared too low, and the performance levels suggested cooling limitations that should have caused major problems. Yet the motor was reportedly functioning exactly as demonstrated. What surprised experts even more was not just the motor itself, but what it represented. Tesla appeared to have once again moved the goalposts in the electric vehicle industry. For over a decade, major automakers have been competing intensely to define the future beyond gasoline-powered transportation. Companies invested billions of dollars in EV development, built massive battery factories, hired thousands of engineers, and expanded electric vehicle production across the globe. Governments introduced new environmental policies, and countless startups emerged, claiming they had finally found a way to challenge Tesla's dominance. In corporate headquarters across Detroit, Tokyo, and Germany, executives developed ambitious multi-year plans to overtake Tesla. Automakers such as Toyota, Volkswagen, Ford, and General Motors publicly outlined strategies aimed at becoming leaders in the EV market. Ford invested heavily in the F-150 Lightning, while General Motors committed significant resources to its Ultium battery platform. The prevailing belief was that established manufacturers, with decades of experience and global scale, would eventually surpass the California-based company. For a period, that prediction seemed reasonable. Competitors released electric vehicles that became more advanced, more affordable, and more appealing to consumers. Charging networks expanded rapidly, and many industry analysts suggested Tesla's growth was slowing. Some even predicted that Tesla's leadership position would soon come to an end. Then, a surprising discovery changed the conversation. A team conducting a detailed examination of a Tesla drive unit found performance characteristics that didn't align with public specifications or with what many engineers believed was achievable in a mass-produced consumer vehicle. Importantly, this wasn't a prototype or a special demonstration model. It was a production vehicle owned and driven by an ordinary customer. The numbers they observed repeatedly led to the same conclusion. What they were seeing seemed impossible. Engineers reviewing the components described them as not merely advanced or expensive, but fundamentally beyond what conventional expectations suggested. The motor appeared compact and unremarkable from the outside, yet its capabilities hinted that Tesla may have already advanced beyond the targets competitors were still working toward. At the same time, Tesla was facing challenges of its own, particularly with the Cybertruck. When Elon Musk first unveiled the stainless steel electric pickup, it immediately attracted worldwide attention. Its unconventional design, ambitious promises, and memorable launch event generated enormous publicity. Many supporters predicted it would transform the pickup truck market. However, reality proved more complicated. Reports suggested that Cybertruck sales fell short of some expectations. Analysts pointed to registration data indicating that a notable percentage of Cybertrucks may have been purchased by companies connected to Musk, including organizations such as SpaceX and xAI. Critics argued that without those purchases, the sales figures could have appeared even weaker. The Cybertruck's struggles highlighted a broader challenge facing Tesla. When the company first rose to prominence, it had relatively few direct competitors. Today, nearly every major automaker is producing electric vehicles. Consumers have more options than ever before, often at competitive prices and with attractive designs. The Cybertruck itself remains highly polarizing. Some buyers admire its futuristic appearance and unique engineering approach, while others view it as impractical, oversized, or unconventional. As competition intensifies across the EV industry, standing out has become far more difficult than it was during Tesla's early years. Yet despite these challenges, discoveries surrounding Tesla's latest motor technology have reignited discussions about whether the company still maintains a significant engineering advantage. If the reported performance figures are accurate, Tesla may once again have introduced technology that competitors will spend years trying to match. As concerns about quality issues and vehicle recalls continued to grow, consumer confidence in Tesla began to face increasing pressure. On Wall Street, analysts openly questioned whether the company's strongest years were already behind it. Financial news programs spent hours analyzing Tesla's delivery numbers, scrutinizing every quarterly report for signs of weakness. The company's stock price experienced repeated declines, investor calls became more tense, and journalists frequently challenged Elon Musk about whether Tesla had lost the innovative edge that once set it apart. Sensing an opportunity, rival automakers accelerated their own electric vehicle programs, hoping to take advantage of what many viewed as a vulnerable moment for Tesla. Musk, however, showed little interest in slowing down. Instead, he continued directing Tesla's focus toward artificial intelligence, robotics, autonomous driving technology, and future robo-taxi networks. The message was clear. Tesla's long-term vision extended far beyond selling electric pickup trucks. At the same time, something remarkable was sitting on automotive analyst Sandy Munro's workbench. His teardown team had carefully documented every component of a Tesla drive unit, examining the rotor, stator, inverter, gearbox, and countless other parts in extraordinary detail. What they discovered told a very different story from the one dominating financial headlines. Rather than appearing like a company in decline, Tesla looked like a company quietly advancing in a direction that much of the industry had yet to fully understand. The technology inside the drive unit suggested not stagnation, but significant engineering progress. In many ways, it appeared that Tesla had stopped competing by the same rules as everyone else. To understand why this mattered, it's important to recognize a fundamental challenge in electric vehicle engineering. For years, manufacturers believed they faced an unavoidable compromise. A vehicle could be extremely powerful and fast, or it could be highly efficient with long driving range. Achieving both simultaneously was often considered unrealistic. High-performance EVs typically generated excessive heat, consumed more energy, and required complex cooling systems. Efficient EVs, on the other hand, often sacrificed excitement and performance. Across the industry, engineers largely accepted this trade-off as an unavoidable reality dictated by physics. Tesla seemed determined to challenge that assumption. At the center of the drive unit that Munro's team examined was a deceptively simple innovation, a carbon fiber-wrapped rotor. Inside every electric motor, the rotor is the component responsible for spinning. As rotational speed increases, enormous forces act upon it, creating stress that can eventually cause failure. Most consumer-grade motors struggle to operate reliably at extremely high speeds. Tesla's solution was to wrap the rotor in carbon fiber, a material known for its exceptional strength and low weight. The carbon fiber layer effectively reinforced the rotor, helping it withstand forces that would damage conventional designs. The results were impressive. The rotor was capable of spinning at more than 20,000 revolutions per minute, speeds more commonly associated with specialized industrial equipment than with passenger vehicles. Yet raw speed was only part of the story. What particularly impressed teardown engineers was the rotor's stability. The carbon fiber reinforcement helped minimize vibration and maintain balance even at extreme rotational speeds. Improved stability enhanced the motor's magnetic efficiency, allowing more electrical energy from the battery to be converted into motion rather than wasted as heat. The advantages began to compound. The motor remained compact and lightweight, required less cooling than many competing designs, delivered enormous torque, and maintained strong driving range. In effect, it appeared to reduce several of the trade-offs that many engineers had long considered unavoidable. One of the most visible examples of this technology's impact was the Tesla Model S Plaid. The vehicle demonstrated acceleration from 0 to 60 miles per hour in under 2 seconds, a performance level comparable to some of the world's most expensive hypercars. At the same time, it remained a practical luxury sedan capable of carrying passengers comfortably over long distances. For many industry veterans, those figures were difficult to ignore. Reports suggest that engineers at competing automakers studied Tesla's published performance numbers with disbelief. Similar conversations were reportedly taking place throughout the automotive world as experienced powertrain specialists found themselves confronting performance benchmarks that challenged long-standing assumptions. For engineers who had spent decades designing traditional drivetrains, the rapid evolution of electric vehicle technology was forcing a major reassessment of what was considered possible. And according to those examining Tesla's latest motor designs, this may have been only the beginning of a much larger story. Back in the Detroit workshop, the teardown team continued uncovering details that made Tesla's engineering approach even more impressive. As they examined the drive unit, they found stator windings arranged to improve magnetic efficiency and cooling channels integrated directly into the housing with remarkable precision. The bearings also appeared capable of handling stress levels beyond those seen in many comparable production vehicles. Each discovery added to a growing list of challenges competitors would need to solve to build something similar. According to automotive expert Sandy Munro, replicating this motor could take rivals years, not months. And by then, Tesla would likely have moved on to its next generation of technology. But performance was only part of the story. The real surprise was cost. The automotive industry is full of impressive prototypes that never became profitable products. Building one revolutionary vehicle is difficult. Building millions at an affordable price while making a profit is far harder. Tesla learned that lesson through years of manufacturing struggles, from production bottlenecks to so-called production hell. Those difficult experiences now appear to be paying off. Tesla has suggested that future drive systems, including motors, electronics, and gearboxes, could be produced for around $1,000 per unit. That figure attracted attention because many competing systems reportedly cost several times more to manufacture. What makes this especially significant is that Tesla appears to be improving performance while simultaneously reducing costs. The company is also working to reduce reliance on expensive materials and streamline component design. Every improvement helps lower production costs, which can reduce vehicle prices, attract more buyers, increase production volume, and create even greater manufacturing efficiency. This creates what industry insiders often call compounding pressure. Competitors face a difficult choice: lower prices and sacrifice profit margins, or maintain margins and risk losing customers. Either option can leave less money available for future research and development. The impact is already visible across the industry. Ford has reported major EV losses, while companies like Lucid and Rivian have struggled to scale production efficiently. General Motors and Volkswagen have also faced delays and software challenges in key electric vehicle programs. As a result, many traditional automakers are reevaluating their long-term EV strategies. One question continues to dominate executive discussions: how quickly can they close the gap with Tesla? Many analysts believe the answer is longer than most companies would like. Among major competitors, BYD is often viewed as one of the few manufacturers capable of matching Tesla's scale. Yet Tesla continues pursuing a broader goal, combining performance, affordability, manufacturing efficiency, and advanced technology into a single ecosystem. If that strategy succeeds, Tesla's biggest advantage may not be any single vehicle or motor. It may be a production system that competitors will spend years trying to match. According to people who attended the meeting, one executive described Tesla's cost roadmap as the most alarming presentation he had ever seen. A single word kept surfacing in reactions across the industry: impossible. First, Tesla's motor performance seemed impossible. Now, its manufacturing costs appeared just as difficult to believe. Competitors were rapidly running out of areas where Tesla wasn't setting the benchmark. But the story extends far beyond electric motors. Many people still think Tesla is primarily a car company. That assumption may overlook what makes the company truly unique. Tesla's greatest advantage isn't just the vehicles it sells, it's the ecosystem built around them. Consider data. Every Tesla on the road continuously collects information about driving conditions, traffic patterns, weather, road layouts, and countless real-world situations. This data helps improve Tesla's autonomous driving systems over time. The more vehicles Tesla has on the road, the more data it gathers. The more data it gathers, the better its AI becomes. That creates a powerful cycle. A Tesla navigating a rainstorm in Houston contributes information that can help improve vehicle performance in similar conditions elsewhere. A Tesla reacting to an unexpected pedestrian in Berlin provides another data point that can benefit the broader system. Every unusual traffic situation, road hazard, or emergency maneuver becomes part of a growing database used to train future software updates. Few competitors have access to data at this scale, and even fewer have been collecting it for as long. Tesla's battery business provides another advantage. Because batteries represent one of the most expensive components in an electric vehicle, Tesla has invested heavily in battery technology and production. The company's 4680 battery cell was developed to improve energy density, lower costs, simplify manufacturing, and enhance overall vehicle performance. Many automakers still rely heavily on third-party battery suppliers, while Tesla has increasingly focused on controlling key parts of its supply chain and technology stack. The company also develops much of its own software, chips, and power electronics. During global semiconductor shortages, Tesla demonstrated unusual flexibility by adapting software to work with alternative chip supplies when many traditional automakers faced significant production disruptions. That adaptability reflects an important difference. Tesla often operates more like a technology company that builds cars than a traditional automaker that uses technology. Its manufacturing network reinforces that idea. Facilities in Fremont, Shanghai, Berlin, and Austin form a global production system that continuously evolves. Future factories in regions such as Mexico or India could further reduce costs while expanding Tesla's presence in major markets. Each factory serves as more than a production site. It becomes a source of learning. Improvements developed in one location can be applied across the entire network, making future facilities more efficient than those that came before them. Traditional automakers often face a different challenge. Many of their factories were originally built for internal combustion vehicles and later adapted for EV production. Tesla, by contrast, designed its newest facilities around electric vehicle manufacturing from the ground up. Then, there's the charging network. For years, some critics viewed Tesla's Supercharger network as simply a convenience feature. Today, many see it as a major competitive advantage. Tesla's charging stations are known for their speed, reliability, and ease of use. Meanwhile, many third-party charging networks have struggled with issues such as equipment failures, payment complications, and inconsistent user experiences. Eventually, several major automakers chose to adopt Tesla's charging standard. Ford and General Motors, among others, agreed to give their customers access to Tesla's charging infrastructure. As a result, Tesla now benefits whenever compatible non-Tesla EVs use its charging network. That's more than traditional competition. It positions Tesla as a key part of the EV ecosystem itself. The picture becomes even larger when energy products are included. Tesla's business now extends beyond vehicles into home batteries, utility-scale energy storage systems, and solar power solutions. Products like Powerwall and Megapack connect homes, businesses, and electrical grids to the same broader energy strategy. Tesla vehicles charge in homes powered by Tesla energy products. Tesla batteries help stabilize electrical grids. Tesla-operated chargers support both Tesla owners and drivers from competing brands. Each piece strengthens the others. Visit a busy Supercharger station today, and you'll likely see more than just Teslas. Alongside them might be a Ford Mustang Mach-E, a Hyundai Ioniq, or a Chevrolet Blazer EV. That scene highlights a significant shift in the industry. Tesla is no longer simply competing within the electric vehicle market. In many ways, it is helping build the infrastructure, software, energy systems, and data networks that support the entire EV ecosystem. Every time a non-Tesla electric vehicle plugs into Tesla's charging network, it does more than generate revenue. It also contributes valuable real-world information about how different vehicles interact with Tesla's infrastructure. In a sense, competitors are helping expand the ecosystem they once hoped to challenge. Across industry discussions, one word continues to appear: impossible. First, it was Tesla's motor performance. Then it was manufacturing costs. Now it's the scale of the ecosystem surrounding the company. With every layer that gets examined, another challenge emerges for competitors trying to catch up, and at the center of it all is something even more important than the vehicles themselves: artificial intelligence. Walk into one of Tesla's AI facilities, and the company looks less like a traditional automaker and more like a technology firm that happens to build cars. One of the clearest examples is Dojo, Tesla's custom-built supercomputer designed specifically to train AI systems using the enormous volume of driving data collected from Tesla vehicles worldwide. Most companies rely heavily on external cloud providers and third-party computing resources. Tesla chose a different path. It invested in building much of its own AI infrastructure from the ground up. The logic is straightforward. Tesla believes its future depends not only on the cars it sells today, but also on the intelligence that powers the vehicles of tomorrow. According to various reports, engineers working on Tesla's AI systems speak about Dojo with the same level of excitement that motor engineers showed when discussing Tesla's advanced drive unit technology. Dojo is more than a powerful computer. It is a purpose-built system designed specifically to process and learn from Tesla's unique stream of real-world driving data. For many industry observers, this level of vertical integration is remarkable. Tesla designs vehicles, develops software, builds chips, operates charging infrastructure, manufactures batteries, and trains AI systems within a connected ecosystem. Once again, the same word returns: impossible. What once seemed impossible in motor design has expanded into manufacturing, software, infrastructure, and artificial intelligence. The reason is the self-reinforcing cycle Tesla has created. Better vehicles attract more customers. More customers generate more driving data. More data improves AI systems. Smarter AI enhances vehicle capabilities. Improved products create additional demand, which funds more research and development. Each improvement strengthens the next. The cycle becomes increasingly difficult to match. As a result, competition in the EV market is no longer focused solely on building better cars. The battle now includes battery technology, manufacturing efficiency, software development, AI training, charging infrastructure, global production capacity, and access to real-world driving data. Catching up in one of these areas would be a major challenge for most automakers. Catching up across all of them simultaneously is far more difficult. That's why the same conversations continue happening in engineering departments and executive boardrooms around the world. The discussion is no longer whether Tesla can build competitive vehicles. The question is how any company can replicate the entire system Tesla has spent years creating. Back in the Detroit teardown workshop where this story began, the motor that sparked so much attention remains a symbol of that challenge. Sandy Munro's team has analyzed it from every angle. They've measured it, tested it, documented it, and compared it against competing technologies. Over the years, the team has examined countless vehicles, from pickup trucks and hybrid cars to luxury sedans and electric vehicles from around the world. They have a well-established process and a reputation for objective engineering analysis. Yet this motor appeared to leave a particularly strong impression. Engineers known for their measured technical evaluations found themselves struggling to describe what they were seeing with ordinary language. Across tear-down facilities, engineering departments, and industry meetings in cities such as Detroit, Dearborn, Wolfsburg, Stuttgart, and Tokyo, a similar conclusion emerged. Tesla didn't simply build another electric motor. According to many observers, it built something that challenged assumptions about what was currently possible in a mass-produced vehicle. And perhaps most importantly, Tesla's engineers are already working on what comes next. While competitors study today's technology, Tesla continues refining future generations of hardware, software, and manufacturing systems. In factories like the one in Austin, drive units move through production lines at a scale that would have seemed unrealistic just a decade ago. Vehicles are assembled using technologies and production methods that continue to surprise much of the industry. Meanwhile, teardown reports continue to accumulate. Production continues to grow. Vehicles continue reaching customers. Elsewhere, engineers at competing companies examine the same specifications, cost estimates, and production figures, trying to determine how they might achieve similar results. Many start with one plan, erase it, and begin again. The same scene plays out across the automotive world. The same question keeps returning. Can any company truly catch Tesla? The technology exists. The vehicles exist. The factories exist. Customers are driving them every day. And while competitors work to close the gap, Tesla continues moving forward. The future of the EV industry remains unwritten. But one thing is clear. The race is no longer just about building electric cars. It's about building the entire ecosystem that supports them. So what do you think? Can another company eventually surpass Tesla? Or has Tesla built an advantage that will be difficult to overcome? Share your thoughts in the comments below and let us know where you think the future of the EV industry is headed.